This conference will now be recorded.
So hi everyone. So today we're discussing DCSCM 2.0. The incubation committee is looking at this contribution for ratification, and just like DCSCM 1.0 didn't really have anything to say much about security. DCSCM 2.0 arrives at a time when the process is pivoting from badging, which we've abandoned, to putting security requirements in templates and having conversations with the security working group. So this is the first time we're trying that. In addition to that, the DCSCM is a specification that is pretty germane to security, so that felt warranted. We do have some visitors, some people who are not usually in the security working group because they're here to discuss DCSCM 2.0. So I'm going to ask them to present themselves, and if they want to provide maybe a 1 or 2 or 3 minute introduction to DCSCM and current goals, because you know I'm seeing a lot of attendees, so I'm not sure everybody knows what DCSCM is. So maybe I don't know. I'm from what I can tell, Siamak and Xiang from Intel are here. Do you guys want to go ahead?
Yeah, I could go through the IC contribution slides, just a few slides to pick from them, just give folks a background. Is that a good way to
That
start? Or
that'd be great if
okay,
5 minutes, something like that, and assume some familiarity, and we can
yeah,
go from there. Thank you. We can see your slides.
okay. So this was the contribution slides. DCSCM stands for Data Center Secure Control Module. This is the 2.0 revision. 1.0 was contributed back in 2000, year two, wait, 2000, I believe, 2001 actually.
2021.
2020, you're right. Thank you. So in this set of specifications, we have the DCSCM2 base specification. This is a build on top of DCSCM1. And the LTPI specification shown here is the protocol we introduced built on top of the LVDS interface. And the spreadsheet is the pinout definitions. We included. You can touch on what's in them, and then mechanical models. That's a reference for anyone to build to the DCSM 2.0 to be compatible with um, other HPMs. So here's a list of contributors. We won't go through them by name. So the process was we had several work streams. Actually, give me 1 second. I think this may not be the latest.
I think you can get more into just the what of what this module is, and less of how it all came together. Maybe.
Right, so I wanted to touch on the work streams. One of them was a security work stream. That's the one I wanted to touch on because they're not all listed here. I think I have a later slide that has more detail. Since we didn't actually do a presentation, we just submitted the contribution by email. Anyway, so in the security work stream, we covered what was the security requirement should be in the DCSCM specification, and of course we invited security experts. I think several folks from this project to attend from the contributing companies. The conclusion was, since yes, it is a security module, but we did not specify any requirements because security is a unique differentiator between companies. So uh, we left that optional for to a decision for designers. So I know you mentioned that DCSCM did not have any details on security, and we follow STEP, and we decided after our discussions that we should follow suit with DCSCM 1.0 since it is a design specific element. So going down to, let's see, let's pick and choose some of the high level of what it is. Okay.
So can I ask a question?
Yes, please.
Okay. Did I understand it correctly that it's a security control module, but there's no security requirements?
Yes.
Interesting.
Well, that's why we're here, right? I mean, so
Right.
it just, Shan, everybody will ask this question all the time, so let's address it today so that we can make
Yep.
the specification stronger. Yeah.
And I can't find the, I think they changed interface. Oh, there it is. Okay, so.
Well, just on that point, this is Siamak. You guys know we've been part of this for a long time together, actually. Brian's very good. Good to hear your voice, Tim and Andres. The DCSCM specification is a base specification, as everybody knows. It is defining the interfaces, but as Shen said, it is not requiring any particular component on the module. It does not define the DCSCM module itself. That is left for a design specification that can specify exactly which components should be on the DCSCM module. So once we get to a design specification, the requirements that security project has will definitely apply.
So is this specification what used to be DCSCI? Like this is just the interface?
There is the DCSCI, as you stated, and Shen can describe the spreadsheet that describes that. It is offering module dimensions so that a particular module can be built so that it can fit in people's chassis, but it is not really a product definition. It is not a design definition. The design definition and product definitions are ahead of us. So individual companies, the same group or different companies, can make contributions that are specifically targeting a particular BMC or a particular root of trust chip or a particular even think of it, flash device or all of that. Those elements being particular and specific are not mentioned here because this is a base specification. It's
it's parallel to the PCI SIG card electromechanical spec that defines the mechanicals, the electricals, the electrical interface functions, the properties at an electrical level, keep out zones, all of that. And but clearly it's so integral to various aspects of managing the system itself that there are certain things that are requirements of the host processor module so that they can work together in a hardware interoperability sense, and then once I recode, I code on top of that and get the full end user functionality. And so there's some suggestions, but not requirements for things around discovery of how do you know what you're coupled to, and some of the binding aspects that we'll want to get into here.
Right, and as Tim is alluding, the counterpart to DCSCM is the host processor memory module, HPM, and that's not part of the definition of DCSCM. And perhaps you guys know that there is a subgroup that is trying to create a system out of a DCSCM, HPM, power module, and a number of other categories of things to put together in a form of a system.
You mentioned that security is a differentiator. Could you give some examples of what vendors have done security-wise to differentiate themselves?
So I can't really speak to what they have done, but just for example, if you look at the components on this module, we have well, it says our root of trust here, but the PROT really should be on this module as well. And the PROT, as we all know, have, they're designed differently from different companies, right? Microsoft has Cerberus, Google has Titan, Intel has PFR. So we did define, include all the interfaces that we could think of, and requested from various companies what their solution will require. We have the SPI interface, we have the I2C interface, we have I3C interface, whatnot, but not the implementation requirements.
Well, I can give you an example if you want an example of what other organizations have done, because I did something similar to this before I joined Intel. We didn't have this module, obviously, this module is just being created. We just used an M.2 card. But with the M.2 card, we were able to afford a number of different services and capabilities to the overall platform, including attestation, including introspection. We could monitor a kernel, we could detect modifications in a kernel, we knew what users were running, we knew what applications they had open, files they had open. We were implementing custom memory encryption, quite a few capabilities, actually. And all of that was enabled through a platform root of trust card with nothing more than a PCI Express interconnect. So
right.
you can look at that type of capability on steroids here.
So
right.
so let me try to, yes, Siamak, 1 second. Let me try to bring a little bit of a point of order here. This card enables different vendors to do the root of trust, but this card degrades the security posture because it builds an easy low-hanging fruit interposition interface, right? And a lot of the feedback that I'm getting from peers, across places like Microsoft, Dell, not just Google, is that is a concern. So the point of today was to address that. I think the point is well established that this is an ecosystem, force multiplier, because different people are going to be able to put different things in their card and satisfy their own particulars. And that's going to allow one common implementation on the motherboard to be much more popular. So I think we're all aligned on that, and it doesn't make sense for OCP security to say those shall use platform root of trust brand X, right? So that's not what we're doing here today. What we're doing though is, and I hope what we're going to be doing is talk about the SCI, the signals that go across that, and how decoupling the motherboard from this card and how adding the possibility for trivial interposition degrades security, and what do we need to ask the follow-on specifications to keep an eye on, rather than have those specifications land with essentially no prior knowledge that these are threats that they require mitigation. So I think Siamak wanted to say something, and I would like Xiang to finish with the deck.
Yes, actually, I'm an incubation committee member within OCP, so I feel all of these projects are my children. I love them all. It is very good that the security project is demonstrating a lot of interest in this DCSCM module that is being worked under the hardware management team. I'm part of the server project, but this is crossing at least 3 major projects. So it is very nice and good that different disciplines are trying to make this one better. The points that Andres just mentioned is an important point. If for whatever reason we have degraded security or manageability or such while adding another feature, it is a point of concern, and we definitely need to remedy that. And it is also good that this team, it seems, that has offered perhaps writing a small chapter or a small paragraph or a method, so that's a guidance for implementers, for design spec developers or product developers, as a guidance to make sure they don't open up a security hole. That's actually very good. The fact that you guys have identified a gap and also identified a solution is a very good thing. That's a wonderful feedback, and that's the reason that individual projects publish their documents. They're looking for constructive feedback so that eventually the end solution is useful for people.
So Xian, you have this deck. Is there something else you wanted to go over before we dive into the threats
I
and
think
all of that?
I think we can dive into the threat modeling. I mean, I think we, like you said, we established the reasons for the call, and I think, well, actually, let me ask, does anyone have any questions regarding what it is before we...
I have a few. I think a threat model around it would be really great. But I have a couple of questions as to what it is. So DCSCM 2.0, I assume there's like a 1.0 and a 1.5 and or is it
Yes,
just straight 2.0?
there was a 1.0, yes. And
was there a threat model on the 1.0? No.
1.0 was a contribution from 2 major companies, and 2.0 is where it opened up to, I think there's about 18 companies now. So it really is gaining traction in terms of adoption for the world. So I can't comment on 1.0. I know the spec doesn't have anything. I don't know if anything was done offline between those two companies. We're definitely focused on this rollout and the amplification of this spec being the one that'll really help it take off.
I see. And in terms of like I think I hear Nate mentioned like a DCSCI, like an interface. Are the 1.0 and the 2.0 compatible in terms of the
No.
interface? Two separate
No,
products?
no, there's some similarities, but it's different in because like we said, 2 companies versus 18, very forward looking. The other ones were 1 generation. This is intended to be a multi-generational approach. So we did physically shift the connector for hardware incompatibility, forcing in hardware incompatibility, but still kept the same name because it is an evolution. There are a couple. There's effectively 3 form factors if you consider a couple verticals coming, but the logical and the SCI is the same. The SCI is a menu of options within the 168 pins of interfaces that you could do, that we took all the company's desires for around mutual exclusive interfaces and created this menu. Then our next step is breaking it down into different groups of companies and creating a design SCI interface spec, which are very specific sets. And really the economic motivation there is each company can make their own SCM or multiple variants, but you don't need to hardware co-design it with an HPM because you can now establish the HPMs within the big swath of the industry, have the exact hardware interfaces within that menu all chosen to be the same. And that's our main focus.
So I got a couple of things out of what you said, is that the hardware interfaces are incompatible. Some stuff changed. So if there was a trap model done in the past, probably not relevant to the new product because they're different, substantially different.
I'm sorry, Brian. Another way of saying what Tim said, the pin assignments on that interface have changed. So by all means, you could say that at the hardware interface, they're not compatible. If you plug a card in there, it doesn't work the same way as DCSCM 1.0 did. But what the team has done for DCSCM 2.0, they have carried forward the principles used for DCSCM 1.0 so that a software stack, a firmware stack, a management stack, even a security stack that was built around DCSCM 1.0 could carry forward to 2.0 the specific implementation within the CPLD will be different, but at a higher level of stack, firmware, even security stack, could be the same if a particular implementation of DCSCM chose to cover that threat model you just mentioned. And another aspect of this point, DCSCM 1.0, if people...
You've already confused me. You said they could be the same, but they're different. So they're either the same or they're different. And then principally the same is not the same as the same.
So can you see my screen? I mean, so for if we're, oh, sorry.
I think we should pretend that nothing happened in 1.0, because anything that we say did happen will be under question. So I think you should view this as a start fresh, threat everything from a 2.0 as if it's the start of day.
I think that makes sense and helps.
So one other thing that you mentioned, Tim, was that there's like a menu of pin definitions, and I know this is kind of getting into the weeds a little bit. What happens if there's like a menu mismatch on like side A and side B?
Yeah, so we have a chapter that we added since the 1.0 called Discovery, and there's some electrical rules to make sure that you can plug and detect without causing electrical stress. You can detect the HPM, which is basically going to get into the very first threat we want to talk about. And then you can choose to halt. You can choose to write rev programmables, even across the interface if you knew, because we've made it rigid how to discover exactly which HPM you're coupled to, down to the serial number level if you needed to. And then there's this other authentication IC piece of it that we want to talk about. But you cannot engage the buses until you know, and you do a break before make kind of engagement of each of these. I don't know, it's about 20 or 30 different interface types.
Is that like a cannot or should not?
There's some companies involved said, I want the ability to bypass certain steps of this discovery process. Conservative people, and I'm talking electrically conservative, security conservative, I'm not built a purpose-built system. It was not hardware co-designed under my control. Foreign peripherals could show up in my supply chain. Those have said, yes, here's a rigid discovery sequence that includes the attestation of the platform root of trust, the attestation of pieces inclusive of the code that's going to be executing, fundamentally being fetched from the HPM host domain, as well as we want to get into the attestation of the HPM was intended to be fully stateless. It is almost stateless, but there is one thing that still has state, and that's an FPGA. So we have a few options there.
There's more than the FPGA with state in an HPM, but yes.
I see. So
it depends. I mean, there's CMOS. There doesn't have to be. There could be other stated. Since we're not dictating exactly what you do, the intent of the theory of operation of the SCM was you try to move the programmables and security kind of function off of that, so that you can, if you have a programmable, update it, but it helps with the whole supply chain and the amplification of HPM reuse into new application.
That all makes sense, but CPUs have fuses, right? And that's both a source of problem and a source of solutions.
Correct. Yeah, we did not go into CPU fusing pieces, which is.
I mean, there's no CPU without fuses, right? So.
Yeah. So Tim, where we kind of come from when we look at stuff like this is, imagine it's a bad actor that's somebody with really bad malicious intent who wants to break every soft rule that you've created to do bad things to the system. And imagine they're plugging in a DCSCM, or imagine they're on the DCSCM, they've gained control of it. What actions can they perform to cause havoc? Either destruction of property, or in the extreme case, exfiltration of data. Those are the kind of things we think about. And certainly making some of the stuff a module does add the the physical attacks that Andreas mentioned earlier, of interposing and compromising a module offline and then injecting it into a supply chain, or just plugging it into removing the module from a system and then plugging it into a malicious one you prepared earlier, just like the baking shows. Hey, here's one I prepared earlier. Physical attacks will form like that. Usually something that's well baked and prepared offline, and then substituted really quickly in a drive-by attack. But I'm also concerned about logical attacks on pin definition on what folks can do, certainly around the programmability of the menu options, and intentionally ignoring things like discovery and going in and doing something malicious.
Yeah, that's right. We agree. And there is the first pass of this. If we accomplish nothing else in this meeting, would love to be able to get through. Paul Vansel on the Dell side he's been working very much on kind of a binding piece of this, so that you do have a two-way attestation of the authenticity, I guess, of each of the two modules with secure GPIO kinds of stuff to prevent any fetch from a foreign card until you've gone through these steps, regardless of what the other card is.
I
So
think
I know that was one of the major first ones, and then there's a bunch of sub threats that we below
so
that.
a couple of things. I think we need to get two problems today. This specification wants to get ratified in the immediate future, not in 2 months or 3 months. So I think we need to do our service here, define the problem space, decide action items. Who's interested in writing this up and making it part of the specification or not, and then move on. I not yet to present our favorite solutions, because we all have our favorite solutions, right? So I'm hoping not just yet. So in the problem space, I'm hearing there are problems with swapping, and then problems with interposition. And I think we can move forward and define a little bit of what we're going to ask people to look into when they implement systems that have DCSCM, right? So a problem with interposition, I have my root of trust, it's amazing, but interposing SPI costs $15 in the data center. So how do I solve that, right? I believe the same could be said of JTAG. I'm not sure, Tim, if you have some opinions there, but in general,
We have one of the items in there is these sort of low-level debug interfaces that traditionally do traverse this type of interface into the CPU domain. JTAG, that's there's some closed box debug. There's a remote debug. That kind of stuff is absolutely one of our things on our list.
So in general, what I'm hearing across multiple folks is there has to be an understanding that this is weakened and it needs to be secured somehow, right? And of course, there's a lot of ways you can secure JTAG and you can secure SPI, but I'd like us to stay focused on that. In general, is there any other class of threats? You were talking about SGPIO and LTPI, I believe.
Well, I think we would say the SCM can be decoupled. It holds code, it holds your platform root of trust, and it's the source of your attestation path into other things as well. The discovery is based on a I2C fru. It's definitely could be altered. The HPM has generally been advertised as being stateless, but we know it's not. You talk about CPU fusing, there's this FPGA. So there's different kinds of mitigations, don't want to talk about now, but if you don't want, but around the immutable attestation, update, and recovery, and those implications are kind of endless on what happens if you don't do that very early in the discovery process, inclusive of bringing up these major interfaces such as between the FPGAs or allowing the FPGA to do certain things. So there are a couple of pretty critical mitigation ideas in there that we'd love people's feedback on, because it could change certain design elements, like does the FPGA have to fetch code from a foreign board, or can it do it locally and then you attest after the fact? Those kinds of principles. the closed box and remote host domain debug. That's one of those where we'd like to be able to establish a spec requirement to avoid. I thought the HPM was going to disconnect this in production. No, I thought the SCM was going to, until you get some kind of certificate-based enablement of those sort of debug target enablement kinds of designs that I know are uh, coming in different manifestations. Um, and then there's other kinds of things around like closed box or remote host debug related to um, avoiding easy bomb connector mods. So we consider nation state down to hobbyist level, and there's certain ones that have been deemed hobbyist level, super easy physicals. There are certain aspects that we can do to make it to raise that bar up. Doesn't raise it to nation state, but above the hobbyist level of I just found the JTAG connector online and popped it and it worked. Um, there's a interface around and a progression toward removing some state like CMOS typically in the host domain, which had BIOS settings and that kind of thing outside of the chipset and putting it on the HPM. Well, that data is readable from the BMC. It's time and CMOS kinds of stuff. So it's readable, but you still need the BIOS permission to make it writable from that domain. So there's different mitigations there. And then finally, all traffic, I think all traffic, it might be most, but I think it's all is unencrypted across the interface. So there are good practices, like DMA into the host memory must be disabled like usual. Um, and then that HPM attestation of the SCM authenticity, it helps assure that there's no rogue BMC firmware that could unlock those paths, but it doesn't say that you didn't, with a foreign um, we think that if you go through that authentication steps, then it creates the binding that allows you to trust. Maybe I'm using the wrong word. That these other interfaces that are unencrypted, traditional spies and I2Cs and things, that you're less concerned about. I guess implants, but maybe how do you address the implants too is probably a whole nother thing when you talk about anything that is a connectorized interface, because the connector in the SCI is published, it's in the public domain. So when I talk about lowering that threat, lowering it down to the hobbyist level, yeah, hobbyist with the pinout doesn't have to do any reverse engineering to go find it. So those are the kinds of things we came up with.
So that sounds like a good list. In terms of actions, considering, yeah,
I
go
have
ahead.
a question. So I noticed on one of the other slides that there was a USB interface. What is that meant for?
There's multiple USBs, and it's actually it's two things. One, it's the host domain. So there may be a trend in CPUs and chipsets to divorce themselves of the USB controllers. So there might be a PCIe USB host controller on the SCM itself. So by doing that, we actually lose a couple of the traditional security functions that you used to have around attach detach detection. And you can always do static port enablement, but you can't do dynamic unless you do something else to get dynamic port enablement, like remote admin ability to open up a port. So that's the host domain. Then there is this big trend, and this is kind of an important one to understand, that the BMC domain for managed USB is taking off, and to the point where it's going to be accepted as an alternate interface into PCIe add-in cards, and is being driven to be fanned out to all these peripheral domains like PCI riser cards and storage backplanes. And there's a bunch of use cases around that related to shared NICs. So a lot of them are Ethernet based on top of the USB, but there's some cases where you can do, say like smart NICs may need a UART or a traditional Ethernet type of interface that's not native USB. There's USB to I3C bridges that can be put out there to actually get the goodness that you ever wanted out, that you thought you were going to get out of I3C doing it native, signal integrity and bandwidth wise. So there's lots of use cases around managed USB 2. So those are sourced from the BMC host controllers. BMC also can be emulated devices, but predominantly fanning out to manage domain things, peripheral subsystems, accelerator trays, all kinds of stuff. Does that answer?
Yeah, well, yeah, it's more than I thought.
It's pretty comprehensive. How do we provide a useful artifact for the DCSCM team to put in their specification? I think what I've heard is a superset of everything I had heard before, and I think there's a decent probability that it's essentially an all-encompassing set of the concerns at play here. So how do we turn this into one page in the specification, such that implementations can actually look at the problem and decide how they're going to deal with it?
Is there not a sort of a baseline, bare minimum for example, they mentioned discovery and doing some judgment on whether or not to let in the HPM, right? Should that be described in the spec? It doesn't say how to do it, but you should do it.
Are you referring to the discovery process? I think we
Yeah,
described the high level of it.
but from a
What's that?
security point of view,
Ah,
wouldn't the discovery process need to document that it does do some security, whether it's attestation or I don't know, however you
We
expect
tried
it
to
to
go
be
down
done.
that path and became extremely over prescriptive, and it didn't go well within the adopters within the group, in the fact that you can't say ye verily you must if I'm a hardware co-designed and I know I have a lock on the building door and I whatever with their supply chain. So it was like it became, all right, if we're not dictating major ICs, can we really dictate? So for example, this authentication IC on the HPM that prevents any code fetch from the HPM into the SCM. That chip, we said this is an optional chip. We think everyone should be doing this, and we think everyone should be doing it consistently. Because if you're not, then this a fru that has to be at this address with this data structure that explains what you're coupled to create a unified motherboard that's used to be one thing is now two things. That we can guarantee some consistency there.
Yeah. Tim, Andres, do you want me to present my couple of slides real quick, and then so that make sure all the everyone understands that context?
I do, if it's if the slides essentially cover what Tim has
Yeah,
described
and
to
he
us.
has prettier pictures about the division of
Okay.
labor.
Pre pictures are good. I still want to end the half hour at 9:30
Sure.
with clarity on what happens next, because the specification is waiting for us.
Yeah. Okay. So yeah, we'll go quick on this. And this is really just sort of a really high level analysis. And so, we talked about what I got on this slide. This just again makes it clear what logic is on the SCM, which is the BMC, the platform root trust, the bias flash, the TPM, and the CPLD. And of course, it specifies the form factor, and then in between there's this connector. So you got a standard form factor, standard connector, and nothing on how you built this other than what's on it is standardized, right? And then on the HPM side, it's got the processor and memory, and there is another CPLD over there. Maybe this authenticator device, if we choose to use it, that Tim talked about, and the for discovery. And again, the form factor standard, right? So that's kind of what the DCSEM is. It's this module with all the security stuff on it, but easy to swap in and out, and easy to swap a DC HPM in and out of a chassis. So first order of magnitude, when I think about it, there's some new threats introduced here. This inherent hardware banding between the platform root trust BMC BIOS and the motherboard and chassis are no longer there. These are standards. So a hobbyist could build a DCSCM that works on somebody's platform and plug it in, intercept the supply chain, physical attack, break it in. Might take him a long time to build it, but he could swap it in real quickly if he hijacked delivery truck or
Yeah,
something.
one of the weird things I want to mention here is that usually, even though there's a variant that could have thumb screws on the outside, like an OCP NIC, it doesn't support hot plug, but that there's variants that we're hoping everyone will use that you need a chassis intrusion event in order to get in there and decouple the SCM from the HPM. There's some but the entity that's logging that event is the thing you're replacing. So it's like
Yeah.
it's
If you just replace the thing that's logging it, you can still, yeah. So
right.
the two threats are it's a lot easier to swap in a clone DCSCM into a platform, than ever before, right? And it could have non-authentic firmware. It could appear just like an authentic, customer A server, and then on a day zero attack, suddenly it's got your ransomware. It's a lot easier to attack this. This is not easy today. This is a new attack. And likewise, since the HPM interface into the chassis is a standard, it would be easier for a hobbyist or somebody to make one and swap that in. So that's our concerns. Now, just kind of analyzing the requirement a little bit. I'll go on the next slide. So again, it's easy to swap these things in because they're modular, right? Not a surprise. I mean, so as I looked at it and started thinking about it, I kind of broke it into like two requirements, two kinds of customers. There's the hyperscale customer and maybe it's not just hyperscale, but it's people that have a very strong remote out of station framework, right? So the the DCSCM that's in that server may locally measure and verify the DC HPM internally and as well as anything else inside the server. But then the remote out of station framework in the data center or bigger would verify the authenticity of the DCSCM and with all of its measurements, and you'd know whether to trust it within your framework. So within this kind of customer's data center, kind of a one-way hardware authentication, the BMC verifying the HPM is sufficient. But and I'm thinking about it, what happens if the server's stolen or in transit or stolen out of a data center and shows back up in a colo? Then it's the same problem as number two down here. You've got a server that could boot and might not have authentic firmware in it. So I call this, for lack of a better term, kind of a common enterprise customer. Common meaning it's very common in a lot of people, but some do better. But the customer often verifies the authenticity of a server when it's delivered using vendor tools or whatever. In some cases, there's audits that run, says, yes, this is exactly what we shipped you, and you've got hash codes and all kinds of things shipped outside of the, separated and through emails or something. Anyway, they inspect it, whatever, but they verify it's authentic. They install it in their data center or the colo, and once it's installed, basically, if the server boots, it's assumed authentic. It has some kind of secure boot, from the platform of trust, and that's a lot of enterprise stuff working that way, right? Now it's going to be easier to swap things out, right, and break that model, make it boot anyway, right? It boots. You swap out the DCSCM with a clone, and it still boots. This model's broken, right? So in this case, we think you kind of need mutual authentication between the DCSCM and the HPM, so that the DCSCM would authenticate the HPM similar to up above, but then the HPM would authenticate the DC SCM as being authentic before it allows it to power on. And it could just be, authentic customer A, or OEM A, it's authentic OEM A HPM. It doesn't have to be a TAT banding between a specific HPM and SCM, but it could, at least you've measured it. You could say it's authentic before it'll power on. That's the policy. The HPM is just, the policy in it is it cannot power on until it knows it's talking to an SCM. So that seems like the key thing, and what is the recommendation? Kind of thinking about it is we don't want to decrease the security with this modular DCMHS architecture in common use cases like number two. We wish everybody was doing sophisticated remote out of station frameworks, but they're not. right? So we don't want to go backwards. So therefore, it seems like kind of a mutual authentication is needed to make sure we don't take a step backwards while the world catches up with the ideal security frameworks. And long term, probably this authentication protocol ought to be part of SPDM. But right now we're building service pretty quick here. The proposal is we can use some off-the-shelf authenticator chips that were kind of targeted for IoT that do a pretty decent job. They're just not, every company that makes one, it's not a standard, right? But over time they could be, and they could be added on the Discovery IDC bus and become part of the Discovery. As Tim said, it's not in the current spec that you have to use this chip and you have to do this. It's just either recommended or allowed to do the authentication. So that's some analysis that I had.
Paul, thank you. I think this is very useful. I think though I'd like to keep it at 3A and not get into,
Yeah. Okay.
Yeah,
yeah. Exactly. Yeah. Exactly. This long-term something is just for those. It's like everyone agrees it probably ought to be part of that. But yeah, that's going to be.
Yeah.
That's going to be So I'll stop sharing if it's.
No, that's good. You can leave it there. I mean, we still
okay.
have 10 minutes of conversation. This is a good slide. Is there anybody else who would like to add anything to this understanding that is forming of the threat model?
Just a comment back on slide 3 or 2. Can't remember.
They're identical. There's more words on 2, on 3 rather.
So the point of DCSM is to allow for differentiation of security, different roots of trust and whatnot. How about TPM? Is that a point of differentiation, or could we improve security by taking that TPM and moving it back to the HPM?
We actually had extensive debate on where this TPM should be. Of course, at the end of the day, we decided that it should be on the SCM.
Well, it is defined as optional, right? It's not.
It's
it doesn't say it should be on the DCSC.
But if you're single node, you should be one. But then ran out of interfaces, and because this thing also supports a dual node, you can independently boot 2 domains via this interface. I'm not sure if that was obvious to anyone because it seems to be a niche, but it is supported there. That in that case, the TPMs would need to be on the HPM. So the affinity of TPM to the CPU socket was the much of the debate of should it be on a security card just because it's about security, or does it actually make sense to be co-located? I don't know if a lot of companies really differentiate on TPM. I know that there's choices of qualified parts and which version of the spec and that sort of, and the big one is the form factor. Nobody's ever, besides embedding the TPM on the baseboard, the daughter card form factor that binds to the SCM, or in the other case, we have to bind to the HPM, I'm assuming, is definitely unique. Nobody's ever tried to standardize that. And our company, we're pretty proud of the form factor that we've come up with compared to some others we've seen out there, just in terms of space and all that. So,
on the topic of, sorry.
Go ahead. I was just gonna say the exact wording we said in the spec is that it is optional, like Casper said, but it is recommended that it's on the SCM. That's how we finally agreed on.
So, like on the topic of booting multiple nodes on HPM, typically you want like a one-to-one relationship between node and TPM, right? And that's why DCFCM 2.0 has 2 channels for 2 different TPMs, right?
It does not. Well, it does if you're using there. My understanding, there's in TCG, there's some opinions around TPM being on a private SPI bus versus shared on a different chip select. And there's different CPUs out there that do different things. That's all I can say. So there are provisions based on the discovery of which mode you need to be in. But if you had 2 independent TPMs that needed their own private SPI bus, that was the one thing that couldn't fit in the SCI. Ran out of pins, basically.
Sure. I guess thanks for that point. But I guess I was trying to highlight is like, if there are two different nodes on the HPM, two independent servers booting up, there will need to be two discrete TPMs on the DCSCM to support those, right?
So the final decision was that you can place one on the HPM with the processor.
You can?
That yeah,
Positive?
because there wasn't enough
There
pins
isn't
on the
enough.
connector.
Yeah.
That was the problem.
Okay, but that's sort of the place where it gets weird, right? Because having one in the SCM, one in the
Yeah.
HPM is like, okay.
Well, we didn't think it'd be a hybrid, but if you wanted to reuse that same exact TPM in a dual node HPM, that's where you could. It could be a hybrid, but there's nothing precluding you if you're creating a dual node situation to put both on the HPM.
Okay.
I'd be interested in learning like why the reasons for putting TPM on DCS, like because from first glance it seems like since TPM is kind of in this world where there really should be one per node, and when the HPM can support multiple, it seems natural to put one or more TPMs on the HPM and leave everything else to the DCSCM. But I need to learn more.
Yeah, a dual node HPM is free to do that, and no connect the bus going to going for TPM use on the SCM, and during the discovery phase, BIOS and BMC will understand that.
So one question about, there's a lot of different pieces here, right? There's the BMC, there's the platform root of trust, there's a SPY flash, a TPM, and a CPLD. Does the architecture say how to uniquely identify that all those pieces go together? Is there a requirement for this module to sort of initialize itself, figure out what its unique identity is, and then guarantee that all those pieces are what was intended, or the pieces that were intended to
That's
be there?
right. That is right. There's a chapter, and definitely recommend people. It's in the public domain on the OCP wiki, and definitely feedback. I wrote it and with help from some others, so definitely we have the editability. We know how to get fixes in there, and it was done originally very specific. And then the more we got into debates with other companies, they were like, "No, I want the choice to bypass a certain step." So we have what from like our enterprise sense, we're like, yeah, we obviously we need to go through this exact attestation flow. We don't over prescribe exactly how to do that stuff, but the order of operations is suggested in there, and it's part of it's around what do you attest in what order in terms of your boot sequence, and attesting foreign devices like the HTML FPGA, for example, go through this authentication step. But then it gets into the electrical interfaces, how to engage interfaces, because you know what you're coupled to one of the earlier questions.
Right.
And
I mean,
really understand what model number you are. That's the new and unique thing here is traditionally you would know what model you are based on which motherboard, but now you're a combination of HBM plus SEM plus maybe other elements in the box that actually decides BIOS and BMC at time 0. You would like to know what model am I for all my code conditionals, but you lose that a little bit, and I think that should be noted, I guess, from a security perspective, that you have to go through certain discovery steps to even understand what model of platform you are.
Yeah, I mean, I think it's very important for the piece itself to be able to uniquely identify and maybe have some sort of secure way of ensuring that all the pieces are in the right places. And the second piece that is really critical is that it be able to report that as an attestation externally, so that somebody can come externally and say, okay, these are the pieces that belong there, and this is how they were authenticated, right?
Yeah, I suppose if we do get like a mutual authentication, then the platform, whatever is in the SCM, it has the responsibility to report. I authenticated with an HPM with components ABC.
Right. What I was thinking is we already have the ability to do mutual authentication to a platform root of trust, for example, right? But the idea in this case is when you're talking to that platform root of trust, you also want to know that that's part of this DCSCM and that you're guaranteed that all those pieces are what you expect.
You mean the other identifiable pieces within the SCM?
Yeah, like the TPM and the SPY, the CPLD, all of those other things, right? That's what we don't have today.
Yeah. Okay, so 928. Thank you very much, everyone. This is super is content heavy in a good sense. So I heard primarily Tim and Paul, and a little bit of Brian and Elaine. So I want us to be able to go back to the SCM team and tell them this is how you move forward. Sorry for the interruption. It was a short interruption, and now we're ready to go. How do we do that?
Just so Andres, so we could start back up the security work stream and invite anyone who's interested to attend and come into a uh, come up with something that is suitable for this specification.
Yeah, absolutely. Thank you. I'm just calling ourselves here that we have an AI and that we need to deliver, right? So I'm gonna do this, Tim and Paul. I'm gonna follow up with you. I'm gonna CC Brian, Elaine, and see if we can put together this into no more than one page, crisp, Python, and give it to the SCM team. How about that plan?
Yeah, I mean, some of us are also on the SCM team, so that works great.
Yeah,
That works
sure.
great.
Yeah.
So I'm gonna follow up this afternoon Pacific time so that we can get this done.
Yeah, I think just the one thing to think about here is I guess I'm a novice at understanding what is like the must and shall kinds of terminology that we would need to put in there. I think we understand quite a few of the, at least the major threats, and then we have lots and lots of ideas of mitigations for each one of those. But what is it that we're actually prescribing you must? So we'll have to go through that in the text.
Let's do the first draft, and
Yeah. Okay. Thanks.
I'm sure Xiang and Stiamak are going to push back on the shells, but yeah,
Right.
that's
Okay. Thanks.
that's okay. That's understood. Yeah. Thank you, everyone.
So
Thank you very
yeah,
much.
so Andre, I guess you could have the first draft and we can review it with the team because we whatever we're putting in the specification needs to be agreed upon by everyone participating. So it's not just Chandler CMAC. I have no authority in what goes in. We run a democracy in our work groups, so
Yeah, of course,
we
of
can
course.
schedule a time to have that reviewed by the team, and we'll
Yeah,
go from there.
yeah. And we'll keep that in mind. I mean, what we write is not going to be it. It can't be too disruptive at this point in the process. So we have an action item to get this to you as soon as possible, so we can move.
Right. And,
Okay.
and by the way, we also have a design spec on top of the base spec. So we have the leeway of another document that's traveling with this, but it's trailing. So there may be some opportunities there just logistically about which spec do you want this in? Is it the card electromechanical, or would this really rely more on like the protocol, in thinking of the PCI SIG parallels? So there's a couple choices.
All right. Thanks, everyone. Thank you for today's session.
Thanks.
Bye bye.
Bye.
Thank you.